Section 4.2 is all about graphing quadratic functions, but this time we're going to look at two different formats, vertex form and intercept form. So you will want your sheet that I gave you. Standard form was on one side. We'll be looking at the vertex form, the opposite side today. Vertex form is written as y equals a x minus h squared plus k. And the vertex for a parabola now will be written right in the equation. What we have to remember is that to get our h value, we need to do the opposite of the sign that you see here. And you will take the same sign as you see for the k value. Opposite sign from the middle, same sign from the outside. And then the a value in the front is considered a stretch value. It will tell you how wide or how skinny your parabola is going to be. Let's go to our first equation. You can fill this in on the slot. Y equals 1/2 parenthesis x minus 3 squared minus 5. Now again, we're going to run through our list. A value in the front tells you if your parabola opens up or down. We've got a positive 1/2. This one opens up. Letter B, is it a max or a minimum? If your parabola opens up, you have a minimum on the very bottom. Letter C is the vertex. Now we can pull our vertex directly out of this equation. Take the opposite of -3, and then the same sign would be -5. Your axis of symmetry, again, is the repeat of the x-coordinate from your vertex. Let's go to our graph now and put these things on here. 3, -5 down here, and then your axis of symmetry is that vertical line passing straight through that x-coordinate. Now for this one, we don't, again, necessarily need to make a table, but what we're going to identify is the y-intercept. So we'll call E the y-intercept. To get a y-intercept, remember, we need to let x equal 0. So we're going to put 0 in where we see x. Y equals 1/2, 0 minus 3 squared, subtract 5. This is -3. -3 squared is 9. 1/2 of 9, and then subtract 5. So that's 4.5, subtract 5, -1/2. So this curve is going to cross at 0, -1/2. We can go ahead and try to place that as accurately as we can on our graph. 0, -1/2 would be about right here. And then again, you've got that mirror image on the other side, so hop 3 spots to your dotted line, and then hop 3 more spots, and stay in that halfway position, and then you can go ahead and make your curve. This next example, again, will be a word problem. A bridge in Washington has 2 towers that each rise 307 feet above the roadway and are connected by suspension cables. Each cable can be modeled by the function y equals 1/7,000 x minus 1,400 squared plus 27. What is the distance between the towers? And then what is the lowest point from the road to the cable? Well, if you look at your equation, it's written in vertex form, which means the vertex to your equation is 1,400, opposite, and then positive 27. 1,400, 27. So if I were to project that 1,427 on my graph, I'd be going this way to 1,400, and then I would be going up here to 27. So this question, what is the lowest point from the road to the cable, would be 27. I believe we're in feet, 27 feet. The other question, what is the distance between the towers? Your vertex is connected to each of the towers. This is the halfway point. So if 1,400 is the halfway point, you have to go another 1,400 to get to the other side. It gives you a total of 2,800 feet. There's not a whole lot of work that has to be done with word problems that are written in vertex form. Typically, the only questions are, what's the maximum height or the minimum height to that middle? And then how wide will it eventually be? That's just double your x value. So very little work, just think about your picture and try to think logically if you can as to what's happening with those. All right, now we're going to go to the next sheet that I gave you. This one will be intercept form. Top of your page, y equals a x minus p, x minus q. P and q are called intercepts. These are actually the x-intercepts. This will be the two places where your curve crosses the x-axis. The x-coordinate of the vertex will always be halfway in between those two spots, halfway in between P and Q. So this will be like doing an average. We're going to take those two spots, P and Q, divide by 2. P plus Q divide by 2. That gives us the x-coordinate of our vertex. And then we plug it in, just like we had to do when we had standard form. These two spots, P and Q, are called your x-intercepts. You will also hear me use the words zeros, roots, or solutions to equations. They all mean the same thing. It's the spot where your curve crosses the x-axis. Let's try this one. Y equals 2 parenthesis x plus 3, x minus 1. So on our sheet, again, we're going to start with the first piece. Does this open up or down? We've got a positive 2. This one opens up. Letter B, if it opens up, we have a minimum. Letter C is now asking us for the x-intercepts. X-intercepts, remember, are ordered pairs, and we need to solve each piece. We're solving for P, we're solving for Q. Pull each one of those out and solve. X plus 3 equals 0. That means x is negative 3. So my first intercept is negative 3, 0. And I can put that spot on my graph, negative 3, 0. The second intercept, pull this out and solve. I get x equals 1. 1 comma 0 is my other x-intercept. Now I need to find the middle, the halfway point between those two. P plus Q divide by 2. Negative 3 plus 1 divide by 2. That's negative 2 over 2, negative 1. That's the x-coordinate. Now we plug it in. 2 parenthesis, negative 1 plus 3, negative 1 minus 1. 2 times negative 2, 4 times negative 2, negative 8. Negative 1, negative 8 will be my vertex. And we can plot that. Negative 1, way down here, negative 8. And remember, you've got an axis of symmetry that passes right between. We can write that equation, x equals negative 1. This will be letter E on your chart, and this was letter D. We have our 3 points that we need to make our curve. As you notice, our intercepts are the same distance away from the axis of symmetry, 2 units away on either side. So we know we were on the right track with plotting those 2 points. Okay, the next thing we have to look at, how can you change from one form into another form? Standard form, vertex form, intercept form. We've looked at all 3 methods. How can you get from either vertex form or intercept form back into standard form? This is called expanding. You're expanding a quadratic. So for instance, if we want to change y equals 3 x minus 4 x plus 6 into standard form, we need to do FOIL. I would keep this 3 out until the very end and do a distribution with 3 through the whole answer. So our FOIL, x squared plus 6x minus 4x minus 24. X squared plus 2x minus 24. Now distribute the 3. 3x squared plus 6x minus 72. There is standard form, an expansion from the original. If we have vertex form, negative 1/2 parenthesis x plus 8 squared plus 35. Think about your order of operations. That tells us we need to do exponents first. X plus 8 times x plus 8. X squared plus 16x plus 64. Remember, that's not just x squared plus 64. You need to get all your terms, oops, this way, and then in here, all your terms. Now, order of operations, we do the distribution with the negative 1/2. Negative 1/2 x squared minus 8x minus 32. And the last thing we'll do is add in that last plus 35. Y equals negative half x squared minus 8x plus 3. And that is now standard form from vertex form. And now we have one last word problem. An object is propelled straight upward with an initial velocity of 80 feet per second. Its height after t seconds is given by the equation negative 16t times quantity t minus 5, where t is the time in seconds after the object is propelled. H is the object's height in feet. How many seconds after it is propelled will the object hit the ground? What is the object's maximum height? Two questions that we need to answer. First thing I want you to notice is that you've got a minus sign out here. That means this is a parabola that faces down. You will have a maximum. That's why they ask you the question, what is the object's maximum height? The other question is, how many seconds will it take to hit the ground? So if this represents the ground, we're going to start right here and throw this object. This is where time is 0. The object goes up and it comes back down and hits the ground. This is the other place where it hits the ground. That's how much time it's going to take us to get there. So if we can find the vertex of this, what's that ordered pair? Remember, that's the halfway point. We should be able to do a double to find out the ending point. We can also look at the vertex and figure out how high this is going to get. So what we have to look at here is, first of all, what format is this in? Now remember, we've looked at two different forms for a parabola, or three different forms for a parabola. Standard form has no parentheses. Vertex form should say something like ax minus h squared plus k. I don't have a squared in here, so I know it's not vertex form. My intercept form is this one, ax minus p, x minus q with two sets of brackets. Well, I almost have two sets of brackets. I've got an a term, that's negative 16, but I don't have an x minus p. I could very easily create one and just call it t minus 0 and t minus 5. Is that the same form? Is that the same equation? So I really have intercept form here, which means these two things will be my intercepts. So if I take each one out and solve them, I get t equals 0, and here I get t equals 5. Those are my two intercept points. Those are exactly these two spots right here, 0 and 5. That's where my curve crosses the x-axis. So I can answer the first question. How many seconds after it is propelled will the object hit the ground? It's going to take 5 seconds to do that. What is the height? Now I need my vertex. So halfway in between, p plus q divided by 2. 0 plus 5 divided by 2, 2.5. I need to take 2.5, plug that back in, and find out what the height will be. Negative 16 times t, which is 2.5, times 2.5 minus 5, that's negative 2.5. So if you plug this in your calculator, it will turn positive, so don't worry about that. Negative times negative is positive. 16 times 2.5 times negative 2.5 should take you to 100. So my overall vertex way up here would be 2.5 comma 100. So my answer, what is the maximum height? 100 feet. Again, another way where you can use a word problem with one of these formulas that we've been looking at, vertex form, intercept form, standard form, to help us solve an equation. You are now finished with section 4.2.